So now, without further ado, we have a stellar lineup of speakers who are at the forefront of this exciting field. So I would like to invite the first of them to the stage, Dr. Ayelet Benjamini. In English, it's Benjamini. In Hebrew, it's Benjamini. Wait a second, Ayelet. I have a lot of things to say about you. Thank you. Thank you. Okay. Dr. Ayelet Benjamini, in her new position, she holds a PhD in computational chemistry from UC Berkeley. She's a director of Google Research here in Israel. She's leading the Climate AI Research Group. And the group's main motivation is to seek effective ways with which we can leverage AI to improve global welfare and to improve the living conditions for all of humankind. I'm not exaggerating, am I? So these are truly noble goals, and I think we can all appreciate them. And Dr. Benjamini will tell us today about how we can accelerate sustainability with AI. Dr. Benjamini, please come to the stand. Thank you. Thank you.
Can you hear me? Great. Okay, thank you, Roey, for this amazing intro. I'm very excited to be here. My name is Ayelet, and as Roey mentioned, I'm a director at Google Research, and I'm going to tell you a bit about what Google does to help communities through climate change. Now, is this going to work? Oh, this one. Okay. Now, as you may have heard today in different talks, Google has been an AI-first company for a very long time and one of the largest investors in R&D across the world. You probably heard the name. But one of our key goals is really to accelerate and transform scientific research. And we do that by applying Google's computational power and the know-how to different problems, from medical diagnosis, through drug discovery, through climate, through agriculture. And we really try to partner with partners just like yourselves and collaborators to make sure that we're really focusing on the most crucial and important problems that humanity is facing, which climate change obviously falls under. We all know that climate change is no longer this distant threat that we need to think about at some point. It's here, and its effects are real and are felt throughout the year very seriously. And we know that, for example, natural disasters have increased sixfold in the last century, both in magnitude and in frequency, right? So this is something that is affecting all of us, but really affects more seriously the more vulnerable communities. And that's why we think that it's even more important to address this at a global scale. And the way Google approaches this problem is by looking at this at a multi-pronged approach, right? We're looking at a time scale around these extreme events, around these crises, and we're thinking about ways that we can help all throughout from way before the crisis even starts. Can we do anything around mitigating the climate change and reducing some of the greenhouse gas emissions, all the way through things that we can do to help planners better plan for the events that are coming. And then while the events are happening, right, it's unavoidable, what can we do to help provide the most effective information to take action in times of need? And then after a crisis happens, how can we help communities bounce back on their feet as quickly as possible? So this is really kind of a full spectrum of different projects that we're looking at. And I wanted to give you a taste today of kind of different aspects of different projects that we're looking at, and then deep dive into one of them in particular that I'm especially proud of. So starting at the very left there, in terms of climate mitigation, we were looking at transportation specifically because we know that it's a very important sector that's contributing to the climate change and to greenhouse gas emissions. And specifically, we noticed that cars in cities, and even more specifically, cars in intersections, are actually contributing up to 29 times more in terms of emissions than cars that are driving out in the free. And the reason for that, more than half of the reason for that, is actually the start and stop events. So these kind of annoying things that you have to stop and then accelerate and stop and then accelerate, it's not just annoying, it's actually bad for the environment. So what we did is actually to leverage AI and Google Maps driving patterns to understand where the traffic is and where can we basically make recommendations to traffic lights so that if you add, let's say, 5 seconds to a turn left or remove 5 seconds from another turn, it will actually make the flow of an intersection much smoother, much faster, and then allow for reducing greenhouse gas emissions. And this is integrated in 12 cities, from Bangalore to Hamburg, across 4 continents. And very excitingly, we see that early numbers are indicating a potential for up to 30% reduction in start and stop events and up to 10% reduction in emissions, which is huge, and that's why we're looking to scale that to even more cities worldwide. Similarly, we were looking into how we can leverage AI to reduce the climate impact of contrails. Contrails are these thin white lines you sometimes see behind airplanes. Apparently, they are a huge factor of what contributes to climate impact of the aviation sector. And we noticed that if we combine weather information, flight data, and satellite imagery, we can see where those contrails are being formed and predict which paths an airline can take to reduce them. We then collaborated with American Airlines, did some test flights, and we see that we can reduce more than half of these contrails by giving those recommendations. If we check to see remote sensing satellite imagery from after the fact, we see that this is actually something that, that is significant and can be reduced. And again, that's why we're looking into how we can scale this with more and more collaborators. Now, jumping a bit to what we can do to help planners, still before a crisis hits, but we know that we can help better plan for what's coming and help cities in particular take action. Extreme heat is one of the most significant crises that climate change is causing, with more than 500,000 deaths annually, and we know that this number is on the rise. And so this is in particular something that we think is important to help address. So what we did is to leverage AI and aerial imagery to understand where and map where in current cities we see tree canopies and shade, which we know is a very significant part of cities' ability to reduce temperature. And integrating that into 350 cities today, we can see both where there are existing tree canopies, but also where we can plan for urban forestry in the future, so that cities can be better prepared. Similarly, cool roofs is another type of mitigation that a city can take, basically change the reflection of roofs, and by kind of providing this map that shows what is the current reflectance, we can help cities say, okay, where are areas that we can change the reflectance of roofs by simply coloring the roof, and so the temperature inside is lowered. And again, a very easy tool in practice, but very hard to do at a scale, and cities often don't know where to look, and so providing them with this information is really critical. Now, jumping ahead to what we do during a crisis, we know that during an event, during an extreme hazard, like a fire, for example, information is really the most critical thing to have. You need to make critical decisions, and every second sometimes matters. And so in hazards and disasters like wildfires, we leverage AI to understand from satellite imagery where fires are, and not just detect that they exist, but really where the boundaries are, and provide this information to users. And we use the surfaces that everybody we know go to, like Google Search and Google Maps, to show you where the fire boundaries are, so you can take the most immediate action. After a disaster happens, we're also there to help communities. We know that first responders and NGOs that are there to help need information to understand where the disaster is, where to even look. It's often very chaotic and very hard to know where to even start. And so we noticed that if we leverage AI and aerial imagery, we're able to detect at scale in an automated way where are damaged buildings and where can we show first responders that this is the place to go. And you can see the kind of before and after images that indicate where we can see damaged buildings. And this is really crucial because it helps provide this information at real time in a time where every hour can matter for disaster management. To do that, we need to actually know first where the buildings are. And I know that it may come as a surprise, but in more than half of the world, it's not really clear that we have the most up-to-date information of where buildings are. In some countries in the developing world, census data could be as old as 30 or 40 years old, and so the maps are really not up to date. And so as a kind of part of that, what we did is actually to understand where buildings are at from satellite imagery, from remote sensing, and map that in a way that's also publicly available and can be used. We map over 1.8 billion buildings across the global south, which covers more than half of global population. And many of those were buildings that were not known before, because it could be very temporary buildings or things that were not covered in current maps. Okay, so that's the full spectrum of from before and after a disaster. But I wanted to also give you a taste and deep dive a bit into one specific disaster and how we are approaching it from an early warning perspective. Floods is one of the most critical disasters that climate change is actually exacerbating, with nearly 1.5 billion people affected every year. Thousands of casualties, lots of economic damage as well. And we know from research before that every day and every second that we can give a heads up about this disaster that's coming, we can actually help users on the ground take action and prevent some of the effects of the disaster. And so we were looking into, okay, what can we do specifically for floods to understand what is available to us to give people predictions as early as possible. Now, maybe not so surprisingly, the data that is available today about basically how high the water is in the river is actually very well correlated with how rich the country is. So in richer countries where the GDP is high, you're going to have more data, and maybe not surprisingly, the countries that are more vulnerable and that are going to be more affected by floods are where we see far less data, and it's far less reliable and more noisy. But we still wanted to see, okay, can we generalize this? Can we learn from the global model something about the specifics of the communities that are more vulnerable? And we did just that. We combined a lot of different inputs, weather inputs from precipitation, snowfall, etc., as well as geographical and geophysical information, basically what is there in the river basins. And the target, the thing that we wanted to predict, is basically what is the level of water in the river at every given point that we have, so that we can say what is going to be the water level at a certain day a few days ahead, right? The model strategy that we use, and I'm not going to go into too much detail, is basically to use an LSTM model. An LSTM-based model, which turned out to be a very easy way to represent a Markovian model of a time series that advances every day, along with a lumped catchnet modeling approach, which basically means that we're modeling the entire basin together and not as discrete units that are uncorrelated. And with that modeling approach, we're actually able to get to really nice results. We're able to predict the state of the art of what is currently available for flood prediction, but at a 5-day lead time, right? So basically, if today you were to receive a notification, okay, the river is about to flood tomorrow, with our approach, you're able to know that 6 days ahead with the same accuracy. And that's really huge for a lot of people who need to take action and need to kind of save their livelihood or save their family. And this was published recently in our Nature paper. This data is available, if you want to see it, in a website called Flood Hub. It's open to all, and this is very, very much a part of what we're striving for, is that this could be available and and can be used by many. Every hexagon here is a point in an area that we have predictions in. The greens are areas where we see that everything's fine, and the reds or the oranges are places where we see that there's going to be an upcoming flood in the next few days, and so therefore there's a warning around it. And if you zoom in to one of those red points, for example, you see on the left that you can get the trajectory. Like, this is what's going to happen the next few days. You can plan ahead. You can see how big the spike is going to be, and basically when is the spike going to be. Right. So last but not least, too much information, but just to say that this thing that I showed in 2 minutes is actually the result of lots of years of work, lots of researchers, and a lot of interaction with the local communities, with collaborators. We've been publishing papers around this along the way because we really want to interact with the academic community, and we really value your feedback around this. So I will stop there, and this is just a list of resources in case you want to.
Thank you, Ayelet. Yeah. Are there any questions? Yoav, please.
Aviv, very impressive, but not sure I understood fully the prediction. Because I come from the physics community. We run numerical weather predictions model. For the hydrological model, is a precipitation.
Right.
I mean,
This is also the input. The inputs include the precipitation, snowfall, a lot of weather inputs.
so you're good as only as the forecast for the precipitation.
Yes.
So who do you take the data from? Noah from
IMERG. This is, I don't know the list off the top of my head, but yes, we're using the kind of standard precipitation weather information. We tried different approaches. I think one of the papers here is talking about, is it better to use just one weather model or actually combine? And we actually see that combining is actually better because the model is able to understand the different biases. We see that some models are better in Global South while others are better in Europe, right? And so having kind of combining those different inputs together actually matters. But yeah, you're right. If the weather data is not good, you're going to be limited by that, for sure. Yeah. Yeah, I'll repeat the question. The question was, is it possible to show the implications of the war before and after? So it's a complicated answer. I think that the models that we have are outsourced, and one can use those to every different disaster. We specifically focus on disasters that are more related to climate. We try to stay clear from conflict zones, and so I don't think that I have an actual report around this, but the model itself should be generalizable. We use it, you're talking about the damage assessment, right? We use it for things like earthquakes and hurricanes and tornadoes, so we know that it's generalizable to different types of disasters, and so I think that in principle it should be applicable to other types of disasters as well. Yeah. Sure. Yeah, so one thing is that this gets updated every day. So it could be that, like I give you a prediction 5 days ahead, and then the day after I kind of course correct, and maybe it was at a high danger level, now it's a bit lower, right? Like obviously the closer we get to the date, you get more information. And yes, after the fact, we look back at all the different disasters that happen, we compare, we update the models based on annual training, and we also have the database outputted outside. It's called Caravan, and people can use it. So we give our predictions, but also kind of what happened in practice, so people can also train for themselves.
Last question? You want
Great question. So FlatHub is available in over 80 countries. As you can see here, we are in constant contact with a lot of both authoritative information sources within countries, but also NGOs and groups that take this information and can act on it. And we have lots of different collaborations to help kind of disseminate the information in practice. Yeah. Yeah. In India, we have millions of notifications that we know that we've sent, and we're tracking those also across other countries, and we have anecdotal feedback that people said, like, this is helping, etc. But we definitely know who we're reaching, and we can kind of follow up on that. Great.
Ayelet, thank you so much.
Thank you.